With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, it is given that there is a bob of mass m which is connected to the length of an inextensible string of length L, and it is released from the position shown in the figure. So it is released from this position, and the length of the string is L, and it is inextensible. Now, if the impact of the bob with the floor is perfectly inelastic, we need to choose which of the statement is the correct option. Now, the statement are regarding the maximum height and also regarding the energy loss. So we need to check what would be the this maximum height which would be attained by the bob after having a collision with this surface, and also what is the loss in the energy. Now, if we just first of all we just calculate, or if we just represent this situation. So initially this was the case that our bob is here. This is our bob, okay, and this is our floor. This is our floor. So what is the distance from here to here? It is given as to be L by 2. Okay, so what is the potential energy at this location? We say that it would be equals to mg L by 2. So when it comes to hit the, we can say that floor. So let's say it is coming and hitting the floor. So let's say here. So from here onward, it would be a circular path. Okay, so it would be hitting here. Why we are saying that it would be hitting here? Because if we see the length is L. Okay, the length is L, but the height is L divided by 2. That means just when it hits the floor, the string, it would become loose. Okay, it would be becoming loose. Now at this location, what is the velocity? First of all, we get the value of the velocity. So we can say that potential energy at this location would be equals to the kinetic energy just before it hits the surface. So we can say that it would be half m v square, or we can say that v value would be equals to under root gl. This would be the value of the velocity. Now what would be the direction of the impact? If we see the direction of the impact, so the velocity would be always tangential to the path. So it would be following a circular path. So the direction of the velocity would be tangential to the circular path. It would be hitting like this. Now what are the various distances? If we just construct our triangle, so we can say that from here to here the distance is L by 2. Okay, this distance is L by 2. Now this is L. What would be this angle theta? So we can say that our theta would be equals to cos theta. This would be base divided by hypotenuse. It would be equals to 1 divided by 2. So that means theta would be equals to what? It would be equals to 60 degree. That means this angle is 60. Now if this is 60, this is 90. So what would be this angle? This would be 30. And this is the tangential and this is the normal. So the total angle here, it would be 90 degrees. So what is this angle? This would be 60. Okay, that means it would be impacting along an angle of 60 degree. Now the impact is along the y direction but not along the x direction. So we can say that horizontal velocity, that would remain same. So we can say that what would be the horizontal velocity? This is our velocity v. So the horizontal component of the velocity, it would be equals to v cos of 60. Okay, at this location it would be v cos of 60. Now what is the value of the cos of 60? It is equals to 1 by 2. So we can say that the horizontal value would be equals to v divided by 2. Now what will happen? From now onward, the string will become loose. So it would not remain tight and it would be following a path like this. Okay, it would be following a path like this with the horizontal velocity which is equals to v divided by 2. Now at the same instant, when it would be coming exactly on the opposite side with the same angle, with the same value of the angle, let's say at this, let's say like this. Okay, now again the length of the string, now the string would be tight and it would be getting a velocity. So what is the velocity at this instant of time? It is equals to v divided by 2. Okay, so this is our v value is equals to under root gl. So v divided by 2. Now so again from now onward the string would become tight and it would be again following a circular path. So what would be the angle here? We can say that again it would be 60 degree when it would try to follow the circular path. Okay, it would be 60 degree. So what would be this angle? This angle would be equals to 60 degree. Okay, the same thing we can just make, if we just draw, so we can say that this is 60. If we draw a parallel line, so this would be 60. So this would be 30 and the correspondingly here angle, it would be 60 degree. So what is the component in this direction? It would be equals to v divided by 2. We just write v divided by 2 cos of 60, and cos of 60 is what? 1 divided by 2. That means v divided by 4. So at this instant of time, it would be having a velocity v divided by 4, where v is given by this expression. Now due to this velocity, it would be rising. Now if we just draw the second instant, so it would be, now the situation is like this. That means it is at this location, from this location, it would be rising. It would be rising. So what would be the height up to which it would rise? Let's say it is rising up to a height of, let's say this is our floor. And we say that, so it is just our floor. It is just here itself. So let's say this height is a small h. So we can say that the energy here, it would be the kinetic energy just at the surface when it is making a contact. So here it would be the kinetic energy and here it would be the potential energy if we choose this to be our datum. So we can say that the value of the kinetic energy would be equals to value of the potential energy. So we can say that mgh, this would be equals to half into m into v. What is the velocity? So we will be taking the velocity as v divided by 4 of the path. Why v by 4? Because it would be the tangential velocity, or this would be the velocity which would be followed by the particle from when it just get out of the surface itself. So we can say that half m into v square, which would be equals to v divided by 4, and we can square this. Now from this expression, we can get the value of h as to be v square divided by 4 square would be 16 multiplied by 2, 32 g. And what is the value of v? It is equals to under root gl. So if we square this, it would be equals to gl. So divided by 32 g. So we can say that maximum height, it would be L divided by 32. So if we check for the option, that means first option is correct and second option is wrong. It is given as to be 0. Now also we need to find what is the energy loss. Now energy loss, it would be equals to what? So delta E, it would be just the change in the potential energy, because initially it was having a potential energy corresponding to this side, L by 2. Now it is having a potential energy corresponding to this side, L divided by 32. So we can say that delta E, it would be equals to mgl minus mg L divided by 32, because now the height is L by 32. Now initially the height was L by 2. So if we solve this, then this would turn out to be 15 divided by 32 mgl, and this energy would be lost. Why? Because the collision is inelastic. So the correct option would be 15 mgl divided by 32. That means D is also a correct option. C would be wrong. So the correct option are A and D. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.